Sir, shall we start, sir?
Yes, yes, yeah.
You can proceed, sir.
Yeah, thank you. So, hello everyone. In this session, I will demonstrate the test bed developed by us. It's named as 5 nines radio. It is a platform for learning the end-to-end 4G and 5G system. So this is the snapshot of our test bed. It has been deployed in Mahindra University, Hyderabad. Okay, first of all, why to build a test bed? So as in the previous session, we have discussed that so the cellular technology developed from 1G to 5G in a very complex way. So there are new kind of services been added, and throughput and all. So the network becomes very complex, both in the access network and the core network. There are many different entire system, very complex. So it's very difficult to model and analyze the entire system. Mostly what we do is we do some research work or study on the focus on the physical layer, right? We talk about the modulation and such things, and some throughput calculation things. But in practice, the network contains many different parts, as we have discussed earlier. Both the access network and the core network has very many inbuilt components that also has to be taken care of. Since it is difficult to model it, how you can go to how you can learn the system, and if you want to propose a new idea towards 4G or 5G, it may not be possible with some theoretical knowledge, right? So we need to have some practical setup that can be used for those purposes. First of all, these particular real 4G and 5G cellular systems within the lab. It's not like doing some small experiment on modulation or reaching some kit and all. It's a full-fledged system that that is capable of running the entire system. So what you can do with the test bed is that you will be able to test your own idea. So if you have some theoretical knowledge, still you can learn and write some publication and all. But you can't test your idea unless you build or having this setup. And you can also build some prototypes for your ideas. So currently, I think 2 years back, probably 2018 end, I think, Government of India sanctioned around 200 crores of fund to all IITs in India to develop full-fledged 5G systems. Been started 5 years back in 2015-16 itself. Different universities had that full-fledged test bed with massive MIMO capabilities and all. But India is a bit late, 3-4 years late. But still, I think now, they started 2 years back. Now it is in the finishing stage. So it's a very hugely funded project that where IIT Madras, IIT Hyderabad, IIT Bangalore, and IIT Kanpur, and IIT Delhi, different organizations involved. Apart from that, so we also developed a test bed that is capable of running these 4G and 5G systems. So though it has limited capabilities, it can emulate many part of 4G and 5G. So currently we have deployed this test bed in Mahindra University, Hyderabad, DIT Mr. Ranji, and we are installing in Goa Engineering College. So if you are nearby these locations, you go and visit these ECE departments, and you can see the test and you can understand how it works. So first of all, what is the 5 nines radio? It's a highly scalable test bed for emulating 5 cellular systems in real time. So it's developed as. So using this, what you can do, and you can create new ideas for M2M and IoT. I can also develop algorithms for running the real system, 4G and 5G systems, like interference management or traffic management, such things. What are the features in this? So currently, it can emulate the entire 4G system. Whatever the monetization we have discussed about the access network and different parts of the core network, right? So all, including the user equipment, you can emulate all. Emulate in the sense, you'll be able to understand the internal functioning of individual components in the whole test bed. Oh, you can actually connect your smartphone to the test bed. It's basically like it's a new operator running the base station. If you put a single access, this particular test bed. As I mentioned, you can actually test your algorithms and ideas. It's highly scalable. That means you can connect any number of towers. Basically, the core network is one part. With the core network, you can connect any number of node Bs, the base stations or the user equipments. There is no limit to. It's like if you suppose we are having this in your lab, you can act like a Geo or Vodafone operator. Okay, so so you can you'll be able to browse internet or make calls and such things. So currently it is supporting 4G end-to-end. If you interface with the USRPs, it can also emulate the 5G. Because the USRPs costly devices around more than 10 lakhs, high-end USRPs 5G system as well. Apart from that, you can also do simulations. End-to-end simulation also possible in the 5G. So basically, this is the typical cellular network, right? So you have phones in different kind of terminals like drones or kind of thing that can be wirelessly connected to the tower, and that is connected to the core network. That core network is connected to internet. So we have to replicate this one in our lab. So how we have done this one is, before that, I want to mention about the core network part, where in the 4G configuration, there is user equipment, there is cell tower, and the core network consists of MME, HSS, SDW, PGW. Okay, the MME is the entity that handles the mobility, right? From hand over such things, mobility management entity. HSS is the home subscriber server. So this HSS will have all your details, also all your SIM card number, IMEI number, all those things will be saved in the HSS. And SDW is the serving gateway, PGW is the PDN gateway. So just I want to explain this one, these 3 steps. Registration, attachment. Registration means whenever you switch on the mobile, that will sync with the mobile tower, cell phone base station. Then the base station will forward the package to MME for authentication, where this user belongs to our network or not. Then the MME will forward the data to the HSS. Then HSS will verify the database. Yes, this particular user is registered with this number, cell phone number, and other things. So it can be authenticated. So then only access to a cell phone. Then the mobile will be attached to the network now. Next is internet connection. So this initial setup procedure, it will be connected. In your phone, you can see that the 4G symbol will be there, right? That is the initial stage, 4G. So still, if then another step, if you enable the mobile internet option, then the EU request connection to the ENOD. Then ENOD will request to the MME. Then MME will send a request to HW. Then again PGW. The PGW will analyze the request from the UE and assign a IP address. Once the IP address is assigned to the UE, then the internet data traffic will go through base. MME will be leaving the coming out of the loop. So we can see the data lines, red lines. That internet connection is through this one only. Okay, this is the typical 4G system. 5G system also similarly same setup, but with the different components names will be there. Like this one, instead of MME we have AUSF, and authentication. Sorry, HSS is database, right? So authentication session function is there in AUSF. AMF is alternative for MME in access mobility function in 5G. SMF is session management function, UPS, user plane function, PCF, policy charging function, those things. So here in 5G, you can see that all the nodes are interconnected. In 5G, sorry, in 4G, it's not such way. It's not that way. In 5G, all are interconnected, and they can communicate each other. This is a 5G setup. Okay. Then in 5G, if you see, these are the responsibility for different components. In base station, these are the responsibilities, as I have explained in the previous session. Bandwidth allocation, resource allocation, and resource control. Those things, measurement and configuration can be done in E0B. Authentication and mobility handling, session management done in core network. So using the test bed, you will be able to see what is happening inside each node actually. That will explain. So as I mentioned, by having multiple E-node Bs, you can actually create a typical cell network in your lab. So you can scale it up. So if the budget is low, we can have it 1 or 2 base stations. But if you have good funding, then you could develop nodes like base station is 7 to 8 such nodes. Then actually you'll be able to do such. You can move from one cell to another cell, and you can see what is happening at the core network. What kind of information is exchanged between E-node B and core network and mobile phone also. So all those interactions can be seen in real time. So this data flow is happening kind of in milliseconds basis, right? So you can make some kind of log or save it in a file. You can see later also. Later real time also you can see. So additionally, with the test bed, we can also integrate another device called 5G IoT bridge. So the IoT 5G, basically the IoT network is the network that running in a kind of Zigbee or Bluetooth kind of thing. They are interconnected. There can be several 10 or 1,000, hundreds of nodes that can be connected. It is a separate entity. That interface is different from the 4G and 5G, right? So for to interface that particular frequency band and all kind of signal processing sort of. So as I mentioned, the two modes of DL connectivity in 4G, right? Those things can be also tested. How the data flow is happening through 4G network and 5G network are both between such things. So these are the different components of the test bed. You could see the core network emulator, ENB emulator, and a UE emulator. So basically, the core network emulator is the kind of your general purpose PC computer only, and that has all the softwares required for running the protocols and algorithms. The 4G access network emulator is the also another unit that processes the baseband samples of collected from the RF unit and doing those functionalities. And RF unit is basically the transceiver that can both transmit and receive both in downlink and uplink. This receiver side, it can be a UE emulator or cell phone or your laptop or your IoT system. Okay, they are connected through wirelessly. This one. So I will explain how we can individually see this performance of the system. Okay, these are some technical specifications. It is a single antenna system, so it is the base station is equipped with a single antenna, but it can also increase to two antennas possible. Bandwidth support is 5, 10, and 20 MHz. As I mentioned, 4G we have 20 MHz bandwidth, right? So we can support about that. So if you use the use up with 100 megahertz bandwidth. This also can be used for 5G transmissions. The operating band is LTE band 7, that is 2680 megahertz. This particular band is not used in India by the operators. They are using 3, 5, 10, 3, 5, and 40. So this is not used. So that's why we are using this particular band. Since the reason is that we do not interfere with other users, and even we will not be interfered with by the neighboring base station also. The interference-free situation, we can analyze our performance. Maximum transmit power is 20 dpm. The coverage range is around 30 meters. So the core network consists of in the 4G configuration HSS, MME, and SDW, as I mentioned earlier. These can be smartphones or 4G dongles or IoT such things. So this is basically the radio unit of the test bed. So user recommend is a smartphone basically. This is the some kind of SDR that can transmit and receive on those LTE frequencies. So you could use any frequency band and operate on it. Is another view of this one. The same picture of that. So these are the responsibilities of access network, right? So all those that modulation and channel coding, all those things are done at the base station. So basically the unit EMB emulator that has software that is written in C language, that will be having all those OFDM modulation, turbo and LVC coding, radio resource management. All those things are there in this one. Scheduling as well. So how the measurement, how the information is transmitted from the unit B, those things we can see. What kind of measurement is taken by UE? Those things can be seen here. So as I mentioned, HSS is basically the home. Is common in 3G we had HLR and AUC, home location register and authentication center. So these two nodes are merged together and becoming a HSS in 4G, home subscriber server. And the MME, I mentioned is mobility management entity that interface with interact with the HSS, and it will also interact with the SDW for internet connection and authentication. Session management. So SPW basically it is having two different units, that is serving gateway and PDN gateway. Serving gateway basically entity that allows monitoring your data flow. Suppose if someone wants to, suppose the police department wants to check your data, what kind of information you are transmitting, so that they can intercept there in SGW. PGW is the unit that basically assigns the IP address and forward the packets to the internet. It is configured with the access point name. Basically, whenever you buy a new SIM card, you might have seen that there's some configuration messages used to come, right? So those configuration messages will be having this APN access point. The routing kind of information will be there. That will explain a bit later. So as I mentioned, there are 3 stages. Initial registration. That means when you switch on the mobile, it will be connected. Connected to the base station or MME. Authentication done. You are able to later on you can be able to make the connection, call or browsing something. Then if you request for internet, then you go to the PGW and get the APSN assigned. Then, so what are we going to see in this demo? First of all, we will see what kind of information is there in core network, how the database is created in HSS and MME, and how to program your SIM card. What kind of information is information to be written in the SIM card, and what happens when the unit B starts, the base station starts. What kind of information is transmitted to the UE and the MME as well. Then you go for EU registration. The EU, what happens when you connect the mobile phone to the tower? What kind of information is exchanged between them? and then PIN connectivity. What happens when you connect the internet? So till now, you have any questions? Hello?
Yes, sir. There is a question in chat box.
Okay.
What is the SDR device used in testbed SDR as trans receiver?
Yeah, so here there is a, hello? Yeah, we have used a STR, something called blade RF, and we can also use USRPs. So depending on your budget, you can go for different configurations. USRP costs around more than 7-8 lakhs. This SDS will cost around a lakh, something like that. But not only buying the SDR, we have to work on the SDR as well, like programming and doing additional works are there. Yeah, there are many different kind of SDRs are there, but they can both transmit and receive. Like Lime SDR is there. Yeah. Okay. So any other question?
Okay.
Can I proceed? Yeah.
Proceed. So there is a question in chat box, sir. Are you able to see, sir? Can I read it?
So IoT.
Yeah. IoT to ITE packet format.
Okay, actually, we cannot invest time on analyzing the traffic pattern. What we did is that we kind of created a IoT sensor network with 10 nodes, and that we have interfaced with the IoT bridge that is transmitting information to the base station. So we have not done any study on that, but we could see that the information we are transmitting is like temperature or sound quality value or air quality value. Those are having very few bytes of data. Like you can see like 2 bytes, 3 bytes, or sometimes some 10 bytes, depending on the sensor value. So very low volume data. And the approximate cost would be, it vary from minimum budget should be roughly 4 to 5 lakhs. So basic 4G test bed requires minimum around 5 lakhs without having GST and tax and all. So any other question? Yeah, that we can discuss later. You can ask us through email or phone, that we could explain that. No, we have not used any USRPs because this, due to this lockdown issue, we couldn't do the purchase and all. So we are planning it in a couple of months. But in the place we have installed the place like Mahindra University and all, they are planning for USRP based setup. Because even each USRP costs around, I told 8-9 lakhs, right? So at least you need two USRP that cost around 20 lakhs. Unless you get some big projects, it will be difficult to do that. So any other question? So someone is raising hand or something. So I will move on.
Yes, sir.
Okay. So I will play a video after some time. Before that, I want to explain some things in the slide itself. So basically, if you consider a city like Chennai or any metropolitan city, there would be many number of cell phone towers, right? So those cell phone towers will be connected to different MMEs, mobility management entities. In a city, there could be different clusters. So each core network, so I mean the mobility management entity could control some few tens of nodes. Okay, so then there is a limit on how many users traffic they can control, right? So like we are dividing cells into sorry, in the region to small cells, right? Similarly, different cells will be grouped together and connected to the MME. So the similar setup, we have to do it in our test bed also. We can see in the top, we have mentioned a max C not B is 8. So up to 8. It can be increased to 16 also. And the max C is 128. So we can keep increasing actually. And we could see some other parameters like MCC, MNC. So MCC and MNC are the some codes specifically used for the country and operator. For example, MCC is called the mobile country code. So its the number is 404 and 405. Two values are used in India. So if you use any cell phone within India, so they will have only these two codes only. Any network you go around any part of India, it should be 404 and 405. But if you go to other countries, suppose you go to France, it will be 208. Or if you go to US, it could be some other number. If you Google it, you get the MCC code. Okay, and MNC is the mobile network code that belongs to the operator and the different state. So within India, if you move around the different places, the MNC will vary. If you are from Tamil Nadu, if you are from Andhra Pradesh or any New Delhi, the number will change. Even within the state, different places will have different numbers. That depends on the operator, such things. And the tracking area code. So again, the tracking area code is basically different. You can see it's like a like one state wise. Suppose if you are moving from Tamil Nadu to Andhra, that code will change from 1 to 2. So from that you could track where you have moved in the network through different. By knowing the MCC and MNC and track TAC values, you could see at you could get the details of time, different time where you were. Such information is possible, and there are different counters are used. There are some deadlines, right? So T3402 and such 14 we can see in the bottom. So those are counters, deadlines used for that, for getting replies and all. So these are the terms used in 3GPP I have mentioned, right? When you make a standard, these are the fixed things. This will be defined in the MME and things. So we have defined such things in seconds, some things minutes also. So these are the configuration in the PGW where we can define the IP range, like what kind of IP address should be assigned to the mobile phone, right? So since the 4G and 5G is fully IP based, so IP network, IP configuration is done at this point. And also called APN interface. You can see APN is right, OAI.IP4. So there is some definite format for that using that APN number also. Okay. So as I mentioned, the fields required for programming SIM card. So we have 3 units, right? Your smartphone, base station, and the core network. So the data you are storing in your SIM card, that should match with the data inside the HSS. So whenever you buy a new SIM card, what do? They create a database for you. Okay, after creating a database, they will program that details into your SIM card. So what kind of details will be stored in the SIM card? MCC, MNC, MSIN. MCC mobile country code, MNC mobile network code, mobile subscriber identification number. Additionally, we need some key, security key, that is called KI, operator code. So if you are from Vodafone or Jio or Airtel, we'll have the different codes, and the operator key also there for each operator, and the service provider name. Suppose if you are seeing your phone, you could see something like Vodafone in IN or Airtel, no? That is basically SIM card, written in a SIM card. So IMS is basically a combination of these things. It's a 15-digit number, whereas MCC is a 3-digit, and MNC is 2 or 3 digits sometimes. MSIN again 10 digits. This will be programmed SIM card and it will be there in HSS also. Whenever you start a smartphone, that will the request will go to the HSS and verify it. Then only you will be able to connect to the net, the cell phone tower. And the IMSS is used only once. Suppose if you are buying smartphone, buying SIM card first time, only for the first time registration, the IMSS is used. That will go to the HSS verification. Later on, the IMS will be changed to another number. This is mainly for the security purposes. That means if someone knows your IMSI, they can manipulate the number and they can behave as same as your SIM card number, and they can get you all your information, right? So to avoid that, security point of view, this IMSI is changed to GTI number in 4G. In 5G also different name will be there, but the similar concept is there. So there are different fields are added. It will be difficult to decode. And if we talk about 2G, in 2G we have IMSI, right? So if someone can listen to the wireless signals, they can actually decode your IMSI and know your phone number and IMSI number, everything. There is a security point of view, 2G is weak, but 4G is very tight in security. Compared to 4G, 5G is having much more better security. So there is a question here. What are conditions to place the base station in area where dense or sparsely users distributed? So the question is not clear to me. So Deepa Naik asked a question, but it's not clear to me.
Hello, sir.
Yeah.
Hello.
Yeah.
Sir, what is the proper position for the base station to get all users better connectivity, like when you are placing the base?
See, actually, when you place the base station, operator point of view, if you see, suppose Airtel is coming and putting base station, no? What they do some kind of analysis using software. In the software, what they do, they will having your map. Suppose you consider city or your region, they will take up a map in that. It will be loaded, and your clutter also loaded. Clutter means the landscape, no? How many buildings are there? Such things will be imported in the software. Then they will do the simulation. They will run it for several days. Actually, it will take several days to run the simulation. After doing the simulation, they will come to know how much signal strength is expected in each region. Accordingly, they will put up a base station. So they will start with some fixed position. Then if the coverage is, if the entire area is covered, they will go with that. If the coverage is not satisfied, they will move the position, location and all. So they have some highly capable softwares to do those things. So that is called network planning. So network planning team will do such things. They will actually simulate the scenario and do it. Yeah.
Okay.
So what type of security algorithm is used in 5G? So the algorithm used for security is that it's called the millenage algorithm. I can write it down. I will show to you. There may be spelling mistake, but we could search it. Millenage. Something like it is pronounced as millenage. So as you mentioned, they also know the population density. So in this region, suppose very few users are there, means they will not put up a base station there. They will reduce the number of base stations in that area. There is a problem with my. So am I audible now?
Yes, sir. Yes, sir.
Okay, okay, thank you. Okay. So these are the basic tools required for SIM card programming. The left side you can see black, right? White color cards. That is basically your blank SIM card. It's empty SIM cards that can be programmed with the data I have mentioned fields. And this is right side is the device that is used for programming your SIM card. So you run the software in the computer interface through USB cable inside the device, and you'll be able to program the data. So this is the kind of software we use it for programming. So is it clear to you? The picture, the numbers are visible to you? Okay, here okay, so you could see the different parameters: read, writing, and the many fails for GSM and LTE parameters. Here, right side LTE, left side GSM. So I'm giving just zooming to LTE. You could see here there is different fields. IMSA 15, right? That I mentioned the IMS number, right? So first 3 digits MCC 208. This belongs to France code. France I used because in India if you use 404, no, so that your phone may not be able to connect to the internet. To avoid the confusion in the phone, so we made it 208 for different country. And is there any question?
तुम्ही चांगलं शिकवायला पाहिजे.
Hello?
ते सांगते मागची ते
Yes.
हे तुमची
Hello? Is there any question, ma'am? So, can my ma'am?
Yes, sir.
Is
Sir?
there any question?
Sir, pardon me, sir.
Is there any question? Someone
No,
asking
sir.
some
No,
questions,
sir.
right?
Yes, sir. But there are no questions in the chat box, sir. You can proceed, sir.
Okay, okay. So, as I mentioned, IMS number, right? MCC, MNC, and the MS number is there. And the other important parameter is KI, the operator security key I told, it is also here. And operator code. So we made it one kind of thing. So whenever you buy a SIM card from the operator like Airtel and all, so they will be having predefined MNC MCC values. As I mentioned, for India we have 405 and 404, right? In this field, and we have IMS ISD number. So this is the 10-digit number. Your phone number is also stored here. So you can see the algorithm used for this in the HSS authentication process. So now I will play a video where you could see the different So now the video is coming, right? Hello? Hello, are you seeing any video here now?
No, sir.
No video is coming?
No, sir.
Sir, it is visible, sir.
Yeah, now it is coming, right? Okay.
Yes, sir. Yes. Yes.
So basically, we opted this terminal mode where you could see the different operations. So first we are running. Ma'am, can we, ma'am?
Hello.
Someone-
Requesting the participants, please mute yourself.
किसी निकल चुकी है वो ना स्कूल या कॉलेज से अप्लाई करना पड़ता है अदरवाइज आप ऐसे खुद होके नहीं जाओगे
Sir, we will.
पूरी जाता हमने लिए नहीं
Oh, there are a lot of noise, ma'am. Yeah.
तो फिर अभी कैसा
We will definitely do it.
तो अभी से वैलिडिटी मांग रहे हैं और वो ज्यादा समय भी नहीं दे रहे हैं ना वो तो 15 तारीख तक ही लास्ट डेट बोल रहे हैं
I mean, Prasant, yeah. I mean, ma'am,
Yes, sir. Yes, sir.
now it is muted, right? Yeah. Okay, the noise is gone now. Okay, so now we are running this HSS. So this is what happens when you run the HSS. It will display the status of the HSS is like how it is connected to the MME and all. So now we are running the MME. So when you run the MME, it will display what kind of nodes are connected to the core network. So you can see that now HSS is connected. I mean, the connection is established between MME and HSS. Here you can see that MME is connected. Then you can see the connected EU is 0. And attached EU is also 0. All are 0 because we have not started the E-node B yet. So once you connect the E-node B, this will become 1. And you could also see what kind of information is exchanged between the different nodes. I will show it one by one. So here we are running the SPGW unit. So I will show you another video that how the E-node B works there. Basically, we had 3 different monitors. We observed it. So we could see when the E-node B is powered on, it is exchanging some information to the between the MME and HSS. So all those information is defined in 3GPP standards. So after the E-node B connection, we could see that the connected E-node B is 1. So now currently 1 E-node B is connected. So if you add many more E-node Bs, the number will be increased to, at this stage, you can connect up to 8 E-node Bs. Yeah, now this particular slide shows, I mean, snapshot shows the attached EU is 1. So whenever the mobile is connected to the network, it is showing as 1 here. And we could see what kind of information is exchanged between these different elements in the testbed. Yeah, so we can just print out all those information. For example, we could see some keywords like PDN and IMSI somewhere, downlink uplink transmissions. So I will show these things in a separate slide as well to the proper zooming. Yeah, you can see that there is some keywords like GTI, I mentioned, right? Instead of IMSI, later on the GTI will be transmitted, right? Data, GTI, IME data, and other information is given here. So you can see that IMSI number is sent to the HSS for authentication. So in the PGW also we can see the different parameters like IMS number is shown and the corresponding APN number. I will explain that what is the APN number in the slides. And once the internet is connection established, the PGW assign the IP address, right? So the IP address is also shown here, the 12.1.1.2. So as I mentioned, the operating frequency was around 2680 megahertz. Yeah. So when you start the E node B, we could see there is a transmission around 2.68 megahertz, right? We set the operating frequency as 2680 megahertz. So we are getting transmissions around this value. And this uplink frequency, the downlink frequency, for uplink we choose 2560. That is should be according to standard. So we can see some dots here, right? That is basically uplink transmission. So if you clearly see, there is a, we have set 10 megahertz operating bandwidth. So what is happening is that yellow color lines are what is that? It is like as I mentioned in the previous session, the broadcast and synchronization information transmitter, right? That you could clearly see in these pictures. That basically in the x-axis we see the time, the frequency. The y-axis time is there. So the time progress, we can see that continuously there is some information transmitted periodically, right? So even though whether the mobile is connected or not, this information will be transmitted periodically. So now in another video we show where the E node B base station is starting, what kind of information is being transmitted between the EU and base station. So the video visible, right? Ma'am, could you see? Could you confirm that the video working?
Sir, it is not playing, sir.
Okay. So,
Yeah.
okay.
Now it is okay, sir. Now it is okay.
Yeah,
Sir.
okay. Yeah, you can see here that there are different components visible here. So there's the received signal strength and downlink physical channel gain, and the NAC and acknowledgement, DCA. You could see some keywords, right? These are the terms used in physical layer of 4G, defined by 3GPP. So now the EU is not connected; it's trying to establish connection. So once, so these are the configurations we defined inside the E-Node. We'll show the different terminologies where you could see MCC and MNC are there, and a different configuration for sending control channels, right? Broadcast and other things. That something called PRAX is there. How much bandwidth should be used? That is also mentioned in this one. So we could see. Here you could see we have mentioned 2680 megahertz. That is the downlink frequency used. For uplink offset is -120. That means 2680 minus 120 will be 2560 is the uplink frequency from the mobile to the base station. We can also set other parameters like a cyclic prefix type. In LTE we have two cyclic prefix modes, normal and extended. That also you can set up, and there are some threshold values for both in uplink and downlink. So those things also can be set here. We can see number of antenna ports set as 1 here, RX is 1. The PLCH resolution is normal. The different parameters are possible. That you have to see the standard, accordingly you have to modify those parameters. Once the EU started communicating with the E-Node, suddenly you can see some new lines, right? The green color lines. So that is kind of information exchange, acknowledgement, no acknowledgement kind of thing. So that is coming. Once it's successfully decoded, it will be attached to the E-Node. So now it is kind of attached. So when this happens, we could see one in the core network. We have seen that, right? Connected EU is 1. So after this process only, when that changes to 1, this was happening. So I couldn't see play the video parallelly. So I'm playing it now. So okay. So you could see the different what kind of frames are transmitted, what kind of preambles and numbers and those things can be seen here. We can also store it in a file and we can see it later on. This is just for visual presentation. So we can see some more green patches where it mentioned that the data is being transmitted to the user equipment. If you have a very good spectrum analyzer, we could also record the data and analyze later. I will show you how to do that. Okay, so now in the previous video, we have seen that in the core network, what happens whenever the node is connected, what is happening. In this particular video, we have seen what happens when you start the E-Node. So next, I will play a video on how these settings happen in user equipment side. Okay, so okay. So this is the stage where we don't have a connection with the E-Node. So we can see the top. We can see that it is it's not connected. It's not showing any signal strength. So I'm starting the demo. Okay. Yeah. So this is the stage where you the mobile is connected to the network. So we saw that, right? It was connected to 1. So when it was connected to 1, we could see the variations in the unit beside also. There will be a full data flow, and in the phone we could see 4G. This means that it is registered. The authentication is done. It is verified that this user is belongs to the network. So in the phone, we have kept the SIM card programmed using this those information like IMSI, MCC, MNC ports. So you can see the SIM card name in the service provider name. We have put 5NR, and we put some dummy value, 10-digit number, phone number. So next, what you can do is that, So I mentioned about the APN, right? So the configuration file when you buy a new SIM card. So in your phone also you can go and check it. So to verify what is the MCC MNC in your phone, you can go to your mobile connections, choose a SIM card and go for APN settings. There you could see different values like you could see APN name is OA8IP4. If it is your Airtel phone, you will be having Airtel GPRS.in, something like that. If it's a Vodafone, it will be name of Vodafone.com, something like that. So you can see it here. The MCC and the MNC is stored here, right? If you open your phone, it should be either 404 or 405, and the MNC can be 2-digit or 3-digit number according to the operator. So now we are enabling the internet. Yes. So that particular section is gone, I think. Yeah. So here we are enabling mobile internet, right? So when you click the mobile data, actually what is happening is, as I mentioned earlier, the data request go to the PG in PGW. The PG gateway assign IP address, then automatically your phone will be connected to internet. So now you can see that 0 kbps, right? So the throughput is only increase, and we can play the video. So as of now, this phone is connected to our test bed in the lab. So we'll go for it will be like a normal internet browsing where you are doing with your Vodafone or any other network.
Sir, to connect IP address, you said one word, sir. Please repeat, sir. I could not hear that. It will connect.
Yeah, actually, when you click on the mobile internet option in the drop down menu, the request will go to the base station. The base station will forward it to MME. Then the MME will forward it to PGW. Then the PGW will assign an IP address for this phone. Okay. Is it clear? So you could see the video. So the browsing is, the video display is happening in our through test bed. Yeah, as I mentioned about the IP address, right? So you could see the IP address in your settings. So you could see here, IP address is 12.1.2. This is IP address range we have configured in our core network. So start from 12.1.1 to 8. So it chooses from here. So in your phone, if you see it, the same IP address will be there. That is assigned by your operator in the particular gateway. So I mentioned about the try my speed up, right? So that you could use it for your checking the throughput performance of your network, right? Same thing can be done in our test also. You can see. So it is connected to Hathway, that's why it's coming up. So the 4G is showing up -77, right? It's very close to the test bed, that's why it's showing -77. Then we'll check the download speed. Again, we move to another place, minus 100 dBm away from the transmitter. We could see another way. You can see the download speed is 1.35 Mbps. The previous case, I think through 3 Mbps, we are close to the base station. We can also get the longitude latitude locations. So we also used another app, Shuttle app. There we can see instantaneous value of the receive signal strength. Yeah, so we can see the instantaneous value, how it varies. It's very close to the base station. That's why it's saying -84 RSRP, -67 or 70. So it's going away from the base station, showing -119, 123. So these are simple tools you could use it for checking the performance, actually transmitting or not, what is RSRP. If you don't have very high quality, high-end spectrum analyzers, you can use your even smartphones to do these things. So after collecting the information, you can get the graphs on how it, because we moved around different places in around the lab. So we could see the values varying from so -123 to -67, right? So we just moved from close to the base to away from the west outer range. So we got from -123 to -67. So we can also see how the received signal strength varied that is about the time. So I will now move to the slides. So now the slide is visible, right? Ma'am, is it visible now?
Yes, sir, it is visible.
Yeah, okay. So as I just in the video it may not be visible to you, so I just made a screenshot to make it clear. So here you can see that before unit B is active, you connected unit B 0 and E is also 0. When this unit B is switched on, it started transmitting 2.68 gigahertz. And the mobile also connected at that time. It was showing the dots here and there. Whenever the unit is on, it will communicate with the MME with a certain protocol. It will share the MCC and ML, like I mentioned, right? So I am belong to this particular cluster like MCC, to statement, sorry, MCC, I'm belonging to this country and this region. So please attach me with this network. It will send a message like that. Then MME will add that to the database. It will be connection is established. And when the unit is connected, you show one. So apart from that, the system information that I was telling about for cell search and selection, the unit B has to transmit information, right? Continuously. That we'll see. This is the frame structure of LT, right? 10 millisecond frames are happening. There is a broadcast channel synchronization and all. So this is the screenshot of our one spectrum analyzer we have used. We could see time and the frequency. In the y-axis is the frequency, in the x-axis is time. So though it is a 10 MHz bandwidth, the control channels are the broadcast and synchronization information transmitted only around the center band. Only center 1.4 MHz only. Around 0 axis, 0. Above 700 kilohertz and below 700 kilohertz, so 1.4 gigahertz, megahertz, sorry, the kilohertz of bandwidth. And you could see, I'll show in the next slide. The cell reference signals are transmitted on the each OID symbol. That also you can see. So the line I got shown here. This let's say. This mark is not coming here. Okay, so this is the starting point. This is ending point. This is basically one OFDM. One slot. So one frame contains 7 OFDM symbols. You can see for first 1, 2, 3, 4, 5, 6, 7, and the first one is having CRS cell reference signals. Second one is empty. This is the pattern used in LTE. And here you can see the PBCH that is called broadcast channel, and the next one is synchronization channel. It's aligned with the BCH. So, like as you mentioned, so user authentication is done in different steps. So there are some questions, just we like to answer it. So Deepa Naik asked, so back of base station connected to optical fiber. No, so we have connected to the unit B using a LAN cable. So all the unit B is connected to the core network via LAN cable. So the bandwidth of base, yes, we have. If you are using 10 MHz bandwidth, the bandwidth will be shared by the different users. If you have 8 users, the 8 users will share the time frequency grids. Yes, exactly. So depending on the load in the network, the bandwidth will be different. So we could actually, if we change the code inside that unit B software, you could record the information what you are asking, like how much bandwidth utilized as function of time. You could get those information as well. So regarding authentication, this is what happening. The UE send a request to the MME via base station. Then it sends request to the HSS. HSS selects generates some random key and a sequence number for verification. The authentication information is sent to the MME. Then it forwards to the UE, and UE also generates some other sequence number that we cross verify with the ones sent by HSS. Here in both UE and HSS, we are using millennial algorithm for the authentication process, and then it sends back the some key value. Then MME confirms that it is belongs to this network. So this is basically function of several parameters, right? Like you mentioned, operator key, what you can use, someone can hack it, right? If someone having the IMSI number, they can manipulate the data and actually transmit their information and get those user information. So to avoid that, they are doing 2 level of authentication process. So this, all those processes can be seen in our how core network site. Basically, you can see that some text is going right. You can see that authentication info started at E1. You can see it here. So you can see that authentication info is started, and so authentication info generated and sent to the MIB back. This is showing diameter success. Authentication is information success. So you can see this. You can further decode what kind of information is transmitted. So you can see that at last, informing NAS about authentication response success for this particular IMSI number. Yeah, this is basically the authentication success response is coming. Authentication parameters are transmitted. So these are the different parameters that is transmitted to and fro. Like I mentioned, RAND, XRE, right? So these are the values transmitted. So like I mentioned here, AATN, XCRS, etc. So now the UE state changed to connected. Here you can see this state is connected. So once it's going connected, then your status will be changed to connected in the. Yeah, this is all happening in HSS side. So basically, it generates some SQ and RAND and all. Finally, verify that its IMS is there and the authentication is done. So it will display some information like this. What kind of sequence data generated using the lineage algorithm there. So here you can see that IMSI number is verified here. There are different parameters displayed. The APN configuration we're talking about, there is a structure of APN. There is a network ID and the MNC number, MCC number, and GPR, something like that. So in all your cell phones, if you open it that APN configuration and see it, it will be in this format. For example, if one knows your network APN, or mobile phone, go to settings, mobile networks, access point names, and select your service provider. There you could see something like internet.mnc. This information basically will go from your mobile phone to the core network for IP assignment. Yeah, as I mentioned, the same thing. Here, this is showing up our information. In your phone, it will be 404 for MCC. Suppose if we are moving from one country to another country, this MCC will be changed to that number according to that, corresponding to that country. So if you have this experience moving to another country, you can see that. So regarding what kind of information is sent to the core network, also seen here. The UE is sending a request for the PDN connectivity. So received PDN connectivity request. So that's what I mentioned there. When you click on the mobile internet, the request will go to the PGW. The request will go like this: PDN connectivity request. Then accordingly, the PGN will assign IP address. So that this is IP address assigned by the PGN. sorry, not, yeah, this IP address assigned by the PGW towards the UEV. That's what I was saying, the UEV side, 12.1 dot, sorry, 0.1, 0.1, 0.2. So after connection, it shows that content is 1. So if you add 10 ADUs, it will be 8. So this is a typical test bed of UVC. So so in the CPU we have installed the E node B software. This is another E node B. In another computer there is a core network software. So core network first has to be started, then E node be started, then EU should be started. So these are the radio units that you are used for transmitting and reception. So moreover, I mentioned about this. So actually, what you can do with this test bed? So as I mentioned, I just I'll give the overview of how to run and all, right? So in the base station, there are inbuilt units, right? What is happening regarding the bandwidth allocation, the scheduling policy, and those things can be modified and tested. So if you have some idea with some scheduling algorithm like the traffic management, those things can be tested within this by changing the code and all. So suppose we have some very good idea about the authentication, some security concept. If you want to try it out, we can alter the algorithm within this HSS and you can test it as well. And if you have some idea that reduces the latency in 4G and 5G, if you want to test it, you can change the protocols of 5G and you can test. You can real time show this. This is the achievement in latency reduction. Something you can show it up. And if you want to test your channel coding algorithm also, we can test those things. So that's it. I am ending this presentation here. You can ask questions now.
Participants, if anybody is having any queries, raise your hand. I will unmute. There is a question in chat box.
Okay. No, what is the question? Can you ask?
We want to learn the implementation, how we can communicate.
So communicate with whom?
Sir, you're done, no, sir? How we can future like scheduling and all? We wanted to learn in more in depth.
Okay. So that if we have the test bed, then we can do that. So I mean that has to be done in C programming. Actually, we cannot use any like Python or MATLAB languages because that is a high level language that there will be a lot of delay. We cannot communicate because the information exchange between the E node B and the RF transceiver, those things are in millisecond basis, right? So that is written in C language for faster computation and implementation. This is mainly the C language.
Sir, it is not possible to learn, sir, like any simulation like this by creating a base. NS2, they don't, NS2 and all we have learned.
Okay.
But there we could not change our protocols. Existing only we are running and we are
Yeah,
testing
so
it.
here you have the possibility to change those things. So all those modules are written in C language. First, you have to learn how it is done. It's all are done according to the 3GP standard. Then you can change it actually. Yes. See, it's not like a simulation kind of. This is a real emulation. So whatever happening in your cell phone tower, that also happening here at the same time. So we can modify all modules and check your algorithms and everything.
Okay, sir. Okay.
Yeah. So any other question?
No, sir, in the chat box. Anybody is interested to ask directly, you can ask.
Sir, if it is connected to a backend by optical networks, like
Okay.
passive optical network, then the capacity can be more enhanced For LTE also, because it is backend supported by more bandwidth.
Yeah, that is right. So as of now, we are going for only 20 megahertz of bandwidth, right? In even the access part, we are 20 megahertz. We don't generate that much traffic. So suppose if you talk about the 5G testbed they're developing in IIT Chennai, you know, that is kind of full-fledged, very bigger level project. So there actually, I think they are using fiber optic based setup. So here we don't need that kind of things because it's a you kind of we wanted to make it like a low cost product. So but still we should be able to do all those things also. So in this case, we are using LAN for information exchange between the base station and this one.
Sir, in routing path and all is taken care, sir, while users when they are reached to particular destination. Means congestion aware, delay aware path, or shortest path, or some path is also considered, sir.
No, actually, this is basically a system done within lab, right? So we don't face that issues here. Suppose if we are keeping this one network here, another network in far away place, I mean some few kilometers away, then you could test that. So since we are testing those things within the lab, those things we may not be able to do it. But within the access network part, you could do. You know, that's a congestion. So if there's 8 users, all want to communicate simultaneously. There is a congestion there. That kind of congestion is taken care of using a random access process, like random access channels and all in LTE.
Oh, okay, sir. Yes, sir. I got it, sir. I got it.
So please tell some specific research gaps in this area. See, so now basically the 5G is the very enhanced version of 4G, right? So the network becomes too complex. Now, as of now, the 3GPP worked for 5 years and made the system available. Now, the system is ready to be deployed. But once you deploy the system, there will be a lot of issues. Like there could be interference. I mentioned about the heterogeneous deployment where both the small cell and the big cells will be there. So when you move from macro to big small cell or small cell to another small cell, there will be frequent handover will happen, and the interference will become severe. And how to control the network in real time will be a complex problem. So in those cases, people start always thinking about machine learning and deep learning approaches. So in those areas will be useful. Like if you work on machine learning and deep learning for interference management and network management or traffic management particularly. If you have IoT and suppose if you have IoT networks, kind of several thousands of IoT systems, how to handle the traffic? So without missing any information, without delay, you should deliver the packets, right? So there still a lot of things has to be done. So development is done, but now it's starting stage for deployment. Once deployment is done, there will be new problems will come here, mainly the interference and other issues. Then a lot of scope for working in that area. So we have this kind of practical demonstrable, I mean, practical test bed, we could actually test those ideas on that. Yeah. So, yeah, sure. So, I mean, these are things I told about real-time network, real-time. So, as I mentioned, the data flow, everything is happening in very millisecond basis, right? How to control the network very efficiently without involving much delay. So, human intervention may not be feasible. In 4G, we could control because we had only macro and micro cells. But in 5G, there are a lot of small cells, new type of services coming up, and how to manage the network itself becoming a serious issue. So any other question?
No, sir, I think
So
you clarified every doubt, I think.
okay, thank you. And if you have any doubt, we can ask us through email or yeah.
So thank you, sir. Thank you very much for your informative session, sir. Sir, if you could share your PPT with us, we will share with our participants, sir.
Okay, so I'm just sharing my email ID you asked. So
Okay, sir. Sir, one more question has come.
yeah.
what is the impact of 5G on internet?
I don't have a specific answer. So the people working on the core network part, they could relate. So I can tell you some of things with respect to India. What will happen? As of now, 4G is more or less deployed throughout India, right? So 5G, as you mentioned, the throughput and the data exchange is very high, and the latency also matters. So as of now, we don't have enough bandwidth to support the backbone network. The traffic will be huge, several exabytes, and as of now, we don't have a proper backbone network to support the traffic. So there is a severe issue when large number of devices connected. Keeping in that mind, the government of India started the project called BharatNet, where they are deploying fiber optic cables throughout India, even rural side, village side. So once that is done, we'll be able to see how the entire traffic is handled in the network side. So and several enhancement also being done at the different working group. There are different working groups for the core network also. So like I mentioned, ITU, the different IT parties are there for internet protocols development also. They are all seriously working on to support this huge traffic demand. Yeah, some online resources. So I will share it with the Karanmay ma'am, so she can say how it later on to you.
Okay, sure, sir, sure.
So any other
Thank
question? Yeah. Okay, ma'am. Thank you. Yeah.
Thank you, sir.
sir.
Thank you very much, sir.
Was there any question now? Someone asking?
Dear participants, tomorrow you are having exam, final exam. That is for 20 marks. Everybody is asking what is the pattern of that exam. So it will be conducted for 20 marks, and whatever sessions are going on till now, the questions will be from the sessions only. Okay. Already the recordings of all the sessions are uploaded in the drive. The drive link also we have shared with you in the WhatsApp group and also as well as in the Zoom chat. Okay. Please refer that sessions, and easily you can answer all the questions because the questions are framed from the basics only. Okay. So no more tension about that exam. Okay. Exam will be carried for 20 marks. The multiple choice. Clear? Any doubt?
No, ma'am. Thank you.
Okay. Thank you, sir. Tomorrow the session will
Hello, ma'am.
start.
Timing, ma'am.
Timing.
We will share that Google form. Okay.
Hello, ma'am.
You can upload. Okay, that's the thing I am discussing. We will share that Google form, the question paper. Okay. So you have to submit on or before 9 o'clock.
Ma'am, sir, through mail or
After
Night.
validatory function, night.
Okay. 9.
Okay.
ma'am, through
Clear?
mail, either mail or
Yeah, Google form only. We will give the Google form link. We'll update in the chat box the Google form link. Okay. So answer the questions, and till the Google form will be opened till 9 o'clock in the night, 9 p.m. Okay. So
Okay.
after 9 p.m. the response would be collected. Okay. Clear? Okay. Thank you. Thank you.
Thank you, madam. Thank you so much. Thank you.